covered solving the first order differential equations through the variable separable method, the separation of variables method. So at the end I've given you this problem. I would actually say that it's going to be separation of variables. All you need to do is bring this to the other side. I'm sorry, there's actually dy over dx. So when you bring this to the other side, you're going to end up with 1 plus x squared times dy over dx is equal to minus xy. So it's very easy to separate them now. So all you are going to do is dy over y is equal to minus x over 1 plus x squared times dx. And now when you integrate it, you can easily do it by the separation of variables method. So always watch out for these kind of small tricks that are involved. It's always better to write down something and check if you can actually do it than just taking a look over it. Now we're going to go to the next method. So when we are going to have this kind of a differential equation, we cannot separate this to the variable separable method. As you can see, you're going to have a function of time over here and also over here. So there's no way that you can actually separate this to this form unless you're going to have q of t is equal to 0. So what you're going to do is, you can separate this into two, saying that q of t is equal to 0 or q of t is not equal to 0. In other terms, it's just a function of time, t. So in this case, you're going to call this as a homogeneous equation. The entire differential equation becomes homogeneous, and of course this becomes the non-homogeneous part. So when it's going to be homogeneous, you can again bring it to the separation of variables form, but when it's going to be non-homogeneous, you cannot bring it back to that. So mainly what I'm going to cover in this video over here is the non-homogeneous part, because it's going to be slightly more tricky to do it. You have something known as the integrating factor, and you definitely need it to solve this kind of a differential equation. Integrating factor is just a simple method that says that when I'm going to multiply by some term on both sides of the equation, it's going to make it into a product rule. I'm going to explain that in a second. And hence, if you're just going to integrate both sides, you can easily find the value of y. I know it sounds a little bit confusing, but let's just take a quick look over what it actually is. Normally, we define integrating factor as something called e raised to the power integral of p of t dt. And yeah, plus c is not required in this problem because we just use it at the end. But what I mean to say is, I'm going to multiply by integrating factor on both the left hand side and the right hand side, and let's just see what's going to happen. So I'm going to have the integrating factor times dy over dt plus the integrating factor times p of t times y is equal to integrating factor times q of t. I've just multiplied throughout by the integrating factor. Now, I would encourage you to actually research on why we have taken the integrating factor as this. So if you're going to look at it, when you're going to differentiate this term, you're going to just get the integrating factor times p of t. It's going to end up like that. You look at it. So all you're going to do over here is the integrating factor times p of t would become just one term now, and if you're going to see, it's going to just be the differentiation of mostly the integrating factor. So this can actually be written as integrating factor times y and the differentiation of this with respect to t. So when you're going to work backwards from here, you're going to do the product rule. So you're going to differentiate the integrating factor, which you would observe it to be integrating factor times p of t. How does that come? Again, you're going to look at the formula. And y is because you have a y term over here, and when you're just going to differentiate that, then ifs is going to stay as it is, and you're going to get this term. So this becomes your left hand side, and your right hand side is just going to be integrating factor times q of t. So now it's pretty easy if you're going to multiply by dt on both sides and then integrate it. So when you're going to do that, if you're going to integrate this term, you're going to just get integrating factor times y. Let's just say it's a function of t, so I'm just writing y of t. And on the right hand side, you're going to get the integral of the term that's being here. So it's the integral of integrating factor times q of t, and you're integrating with respect to dt on both sides. That's how you got rid of this. So I'm going to do the same thing on this side. So I'm going to get a dt. And so another thing for y of t is simply 1 over the integrating factor times integral of if times q of t dt, and after you integrate it, you will be getting plus c. Plus c is again very important. So this is how you can solve for y of t. So over here, after you solve this, you're going to be careful with a few things. The main thing that you have to keep in mind is not to forget this plus c. This is very important. This is going to be your number one condition. When you're going to check your answer, this is definitely going to be there. After you get the answer, you might have, if you feel that your answer is not correct, that might be because of this reason. Many people tend to do this mistake. So this is going to be the second area of check. But when you're going to do the solution, it obviously works the other way around. Because let's say for an example, I'm giving you this problem, pretty straightforward problem. I'm just gonna do it there randomly. In this one, many people would tend to just take p of t, sorry, 2y. I'm extremely sorry about that. Many people just tend to take p of t as 2 over here. Remember, it's actually not 2. You have a negative which is in front of it, and you can do all of this only when it satisfies this condition. It should be of the form dy over dt plus p of t times y is equal to p of t. But over here, we are having minus p of t. So the minus is actually part of the p of t. So minus this, taking it as plus 2 is definitely wrong. You're going to take p of t is equal to minus 2 to actually solve it correctly. So this is all about the integrating factors. I could actually give you some practice problems on this. Maybe I'll add a new video just summarizing the different problems and what to do with this. Thanks for watching.